All right, CNT125. We're about to move into the VLAN section of Chapter 8. But before we do that, let's refresh our memory on some things about switches, because VLANs are implemented on switches, so we need to remember some basic things about switches. Switch is a connectivity device that's going to subdivide a network. It's going to segment it a little bit at layer 2 because it operates at layer 2. Traditional switches operate at layer 2, data link layer, reading MAC addresses at layer 2. And a switch is actually going to maintain a table of MAC addresses, layer 2 addresses, to make decisions on where data goes when it receives it. So data coming into a switch, it'll pick it up, look at the MAC address and go, "Ooh, I know where that is," and send it out only the port that's attached to that MAC address. "Oh, it's in port 12. Boom, here you go. Oh, it's in port 8. Here you go. Boom." Okay, that's what your switch is going to do. So as I take a look at examples like this, that's what this picture is trying to show you. When data comes in a port, when data comes in port 1 here, the switch goes, "Ooh, I know where MAC address 2 is," and sends it out only this port here. Comes in this port, "Hey, I know where that is," and sends it out only to port computer MAC address 4, if you will, showing that we can actually have two simultaneous conversations going on in our switch, hence the higher throughput in a switch. Here's various forms, 24, 48, a couple hundred port switch, various forms of switches. Reminder on switches too, these far right ports are typically the uplink ports. So over here on the left, these copper ports over here, if they are 100 meg ports, these uplink ports on the right are typically gigabit, a factor of 10 more. On the left, if these ports are gigabit, then these ports on the right are typically 10 gig. Okay, these are typically 10 gig uplink ports to accommodate, all of these workstations flowing through these ports. Now you'll notice on modern switches here, as you look, it almost looks like an empty port. These are typically SFPs, small form pluggable ports. Hopefully you remember that from 120. The little adapter that you can slide in that allow you to plug in a copper cable, or you slide a different SFP in, you can plug in a fiber cable right into that SFP port. That is very common today on modern switches that you buy. If I were to open up the switch, I see it's basically almost like a purpose-built computer, power supply processor. This is a whole series of NICs, if you will, for the ports going in and out, the data moving in and out. Typically, I plug my switch in the network, workstations plug into it, devices plug into it in a star fashion, if you will. On a home network, that's all I need to do. On a large facility like school here, or schools or businesses, you actually need to plug into the switch and start configuring using commands to tell it what things it needs to do. So there actually is a configuration process on most switches in a commercial or business environment. Reminder too, also, don't forget about these collision domain, broadcast domain things. The reason we use switches today is they are actually layer 2. They do have some intelligence. So what they do is, as we said before, as data comes into the switch actually tries to find what port to send it out. And that's good because it's the switch is not sending it all ports and going to everybody. When it did that, all the workstations would be waiting for each other or colliding with each other, and our throughput would be horrible. So with our switch, trying to get it out only one port to the destination, we can have multiple conversations going on at once and no collisions occurring, or essentially no collisions occurring. Switches are, around 97% kind of thing, almost no collisions. And that's thinking back to the picture we showed before. This hub, all these workstations are sharing the bandwidth, so they're all one giant collision domain. The switch ports, each one is their own collision domain, meaning they're not competing with anybody, they're not sharing with anybody, therefore they get full bandwidth. That's the idea behind that. Don't forget your broadcast domain thing. Anything layer 3 or above is not going to pass broadcasts, including VLANs. Okay, they're going to filter or stop or contain broadcasts, however you want to think about it. They have enough intelligence to say, no, I'm not going to pass that broadcast traffic on to another floor, another building. Hence why when you see a layer 3 device here, a router sitting in the middle, it broke the network in half. This is a broadcast area over here. This is a broadcast area over here. In other words, if a workstation here emits a broadcast type traffic, whether it be a protocol like RIP or ARP, that kind of thing, it's going to hit the router, and the router's going to say, no, sorry, you're not going to go on beyond here, sorry. And it's going to contain that. It's going to keep it on that floor, that part of the building, etc. Don't forget the collision domain, broadcast domain thing when we talk switches.